Hi everyone, this is the part 2 of using T-Mart to correct for the adjacency effect in optical remote sensing. In part 1, we talked about what the adjacency effect is, how T-Mart corrects for it, and how to install T-Mart. In this video, we're going to see how T-Mart can be used and to take a look at its output. Data page of T-Mart. We first scroll down to the Quick Start menu for adjacency effect correction. And then we copy the code block here. And then we open an empty Python script and we paste the code we just copied. Here we have a dummy path to a satellite file. I'm going to replace it with the real path. I have a Landsat 9 image here. And then we also have dummy credentials here. My username is YW46, and I'm going to have my password here too, and then save the file. T-Mart requires an Earthdata account. You can get it by first going to the documentation page of T-Mart, and then click Instruction Adjacency Effect Correction, and then there's a hyperlink to your Earthdata account. Here I'm logged in. You can first register for an account and sign in, and then go to your application, authorized apps. At the very bottom, there's approve more applications. And the central one we need is ob.dac data access. Then click authorize. And then it says application OBDAC data has been added to your authorized applications, and that's great. Now you can use your username and password in T-Mart processing. There are multiple ways you can run T-Mart. One is through an integrated development environment, such as PyCharm and Spider. And you can also just run it in your terminal. The way to do it is to first activate your environment for T-Mart. For me, that is T-Mart, and then you can just write Python and then drag the Python code into the command line interface, and then click enter. And now it runs. It's first downloading ancillary files, and then retrieving the atmospheric information from ancillary file. Then computing masks, and then plotting the extent of water. And then the entire processing will take around 20 to 30 minutes. Processing is now done. By default, T-Mart creates a copy of the satellite files and operate on the copied files. But of course, we have the option to operate on the original files too. And you can do that by going to the instruction adjacency effect correction under overwrite existing files. It tells you that by adding overwrite equals true to the run argument, to the run function, you can operate on the existing files. Now, let's take a look at the satellite files processed by T-Mart. The first one we'll look at is the T-Mart log file. It records what was printed in the Python console, and it can be great for debugging and going back to see what settings we used in the processing. Then there's AEC completed, and it records the bands that were corrected for adjacency effect. Then there's the T-Mart ATM info, and this file records the ancillary atmospheric information used in the processing. The ancillary files can be found in this folder, T-Mart Ancillary, and they are in netcdf format. And if we go back and we scroll down, there's the T-Mart preview.png. And it shows the extent of pixels modified by T-Mart. By default, T-Mart modifies water pixels only, and it uses a few criteria to identify water. The most important one is the threshold in the reflectance of a shortwave infrared band, roughly at 1600 nanometers, and the default value is 0.03. And all the criteria can be modified, of course, in the code. And for example, if your target water body was not modified by T-Mart, you should take a look at the water's reflectance in the original image and modify the threshold accordingly. And the way to modify the criteria can be found in T-Mart's documentation. Lastly, let's take a look at the image processed by T-Mart. Here I opened the two band5 files before and after adjacency effect correction in QGIS. And I have this tool, terrain profile, that can show us the difference in the reflectance of the two layers along a transect. Let's first add them into the tool, and then we can go to a water body and then draw a transect. And here the top line is before adjacency effect correction, and the bottom one is the one after adjacency effect correction. We can see that the increased reflectance near the shore was largely corrected for. With the level 1 or top of atmosphere reflectance files corrected for the adjacency effect, you can use them as input to atmospheric correction processors and get better surface reflectance retrieval. That is all for this video tutorial. You can find more information on the documentation page of T-Mart. Please also feel free to email me anytime to ask questions. I'd love to hear suggestions and feedback too. Thank you.